by now, on a system, you should be able to list the users on the system. You know, you can look at the GUID for hints about which systems are, or which users are system related and which users are added after the fact. You should be able to set the password of any user as the root user. You should have no problem getting a command prompt as root. You should have no problem switching to a normal user. The one thing that I didn't show you is changing to a particular user as one user. So unlike on Windows, where assuming the identity of another user is a problematic thing to do, Microsoft doesn't believe that that's a good idea from a security standpoint. You can assume the identity of another user. Now, on Linux, there's still a paper trail of sorts showing that, you know, you as a normal user, let's say that my Wendell user logged into the system, and then I became root, and then I became the Bob user to look at Bob's stuff or troubleshoot or whatever. There is going to be a record of that in the system. There's going to be a paper trail of that. Microsoft thinks that that's too dangerous, that is not something that should be permitted. Somebody could spy on somebody else's email. There's maybe not as much logging, maybe not as much of a paper trail that anybody would notice. And so this is not something that Microsoft allows for easily on the Windows platform. It turns out that you can still change the permissions, like change the permissions on a user's mailbox at the Exchange level, change the permissions on the system, change other system permissions, advanced system permissions, and accomplish the same thing without actually logging on as a user. So in terms of like security and data protection, the point is moot. Like you can't, an administrator on the system can always get to the data in a quasi-surreptitious kind of way that if you're not looking for specific things in the logs, you're still going to be able to get to it. On the Linux side of the world, it's super useful to be able to log in as somebody to help troubleshoot issues. From a user privacy standpoint and a user control standpoint and an auditability standpoint, like maybe you want to log in as Bob and do something bad to get him fired or something. You know, those are not good things, but those are unfortunately things that you run into in the workplace. And so having auditability and an audit log and a trail for that kind of stuff is very important. Another thing that you'll run into, and we'll cover this in the advanced course, is actually having a system where the logs, copies of all the logs for what's going on in the system, are shipped to another computer. So the logs for what's going on this computer are not actually even stored on this computer, they're stored somewhere else. And that's kind of a built-in thing for Linux systems. It's called remote syslogging. Systemd has a pretty good interface for that as well. It's one of the you know, Systemd, it's been kind of a rocky thing in the Linux world, but the remote system log capabilities and some of these other features are features that the enterprise has basically been demanding for the better part of the last 5-10 years in the Linux side of the world. And there have been various solutions, but nothing super robust and automated. I don't want to say until Systemd, but Systemd really took some of the teeth gnashing out of setting up those kind of things. So I don't know. It's the thinly veiled praise of Systemd. Everybody loves to hate on Systemd, but it does do some important stuff for, you know, management. And we'll talk more about Systemd and how that's important next. I'll also show you one other command line command, which is typically installed on the system. It's called W. And so if you type W, it's it's sort of a long version of who that's a shorter command. So it's another one of those less is more jokes, right? So W shows you, you know, this system, it's been up for 10 days. There are 4 users logged in. There are 4 user sessions. The load average, which is how busy the system is, how many processes are waiting on something. And then the user, the TTY, which is where they're connected on the system. From would show if they're a local user or there would be an IP address there if they're a remote user. It'll show you the last time they logged in, how long they've been idle, the CPU usage, the user CPU usage and some other things, and then what they're doing. And so in this case, it's like I'm running the GNOME session, and then I've got 2 terminals, and then GNOME terminal server. And so who is just a version of that shows you who and where and when something is logged in and how something is working and you know, all that kind of stuff. So not really, you know, there are ways to be logged in and not show up here, security issues, but generally, unless you have a miscreant or somebody that's trying to misbehave, people that are actively logged into the system, you can see with this command and that sort of thing. There's also another command called last, which will show you the last time that people logged in and the last time that anybody did anything. And so it's like, okay, we had system reboots and there was a system crash here. And this is the last they were logged in for this long to this long. So last is sometimes really handy, and this shows you when the last log begins. And so in this case it begins Sunday, December 3rd, but it can go farther back in time. Just depends on your system. There's one last thing that we'll talk about with authentication, and it's really just a mention. So we've covered the password file and the group file and login and resetting the passwords, but this is really just on one local system. What about like in the enterprise? I mean, I'm sure around your business you've probably heard Active Directory or LDAP, Lightweight Directory Access Protocol, or maybe Kerberos tickets, just stuff like that. How do you handle authentication in a shared medium like that? Well, with Linux, you can totally enroll a Linux machine in an Active Directory domain, or you can use LDAP for authentication. In fact, there are a large number of plugins that Linux supports in order to do authentication against third-party systems. You can even integrate Google Authenticator in your system when you log in. And the mechanism for that is called the Pluggable Authentication Module, or PAM. And so there are PAM components that will let you do things like Google integration, or YubiKey, which is like a hardware login system, or any number of other things that will let you authenticate against a third-party system and log in. Or in the case of like the Google Authenticator, you're still logging in locally, but it's not going to let you log in until you answer a challenge response issued through Google. You set all that up through PAM, through the PAM system, and entire books have been written on PAM. So, like everything in this course, like SED and AUK and VI, and now PAM, and we talked a little bit about OpenSSH. We're getting ready to talk a lot about OpenSSH. Pretty much every heading in this entire course, hundreds and hundreds of pages of books exist on those topics. So we're really only hitting the highlights. But in terms of like, I need to be able to log into my system and have it integrated with another login system somewhere else. Yeah, it'll totally do that. The thing that reads from the local password file and groups and users is modular. And so if you don't want to read from the local files and you want to just use LDAP or Kerberos or whatever, you totally can do that. That is completely an option, but that's going to be a more advanced option. This is just the introduction. Now that we've added the devs group, let's do something interesting with it. So I'm going to go to slash. I'm going to go, let's see. I'm at slash as root. I'm going to go to the opt directory. I'm going to make a directory called devs. And I'm going to use the command chgrp, which changes the group of a directory or file. So I made this directory, which would have been owned by root, and the group would have been root. And I just changed the group from root to devs. We can see that the group has read and list contents permissions. I'm going to do chmod to change the mode, G+W, which will add group write capability to the devs folder. Now, if you're not familiar with chmod, you should read the man page for chmod, because chmod is handy. Now, if you want to specify not G+W group plus write, we could also do it as octal, but with octal, we would have to specify the existing permissions, which would be 775, because 4 plus 0 plus 1. You should still be familiar with permissions from the previous section, so hopefully that'll be pretty good. Got chmod 775, the devs folder. And there we are. Now I've become Wendell, and I'm going to touch something, and look at that. I have the file A, but I've got file A, which belongs to me. My group is not going to be able to do anything with it. We could do Wendell, being a member of the devs group, has permission to change the permissions. Now, if my default group was devs, when I create a file or do anything with a file, then it's automatically going to belong to the devs group as well. So that's cool that works, but it's a little, shall we say, cumbersome. Let's see if Chmod has anything useful for us. Now, the Chmod man page is not really super long. It's only 126 lines. Set UID and set GID bits. Chmod clears the set group ID bit of a regular file if the file's group ID does not match the user's effective group ID or one of the user's supplementary group IDs, unless the user has the appropriate privileges. Additional restrictions may cause the set user ID and set group ID bits of mode or R file to be ignored. This behavior depends on the policy and functionality of the underlying Chmod system call. When in doubt, check the underlying system behavior. Chmod preserves the directory's set user ID and set GID bits unless you explicitly specify otherwise. You can set or clear bits with symbolic modes like U plus S and G minus S, but you can set but not clear the bits with the numeric mode. Okay, so that's really dense language, but let's look at what just happened. I created a file. I'm going to remove it now. I'm going to go up one. Well, I'm Wendell. I need to become root again. Okay, so I'm in the folder here. And it sounded like I could do something like Chmod G plus S. Is that what we wanted to do? G plus S devs. And so I think based on the description, because it talked about G minus S and O and set UID, I don't want to set UID. I don't want stuff in this directory to automatically become root if the users have permission. Note that in the man page it said if the users have permission. I don't want stuff to happen as root in this directory. All I really care about is the devs group. This is a pretty common pattern that you would run into in like a business type setup. And this is going to be the same on Red Hat, as Debian, as OpenSUSE, pretty much any system under the sun. And the even more advanced things with file system ACLs, but we're just at a very basic level right now, believe it or not. So Chmod G plus S devs. And so this is going to tell it, hey, I want the group to follow the user if the user has permissions. So I'll do Chmod G plus S devs. I will become the Wendell user again. Which sounds really weird saying that in the third person. I'm going to go in the devs folder here, and we're going to do touch A again. And look at that, A automatically belongs to the devs user now. Hey, that's like a thing from the Fonz, which nobody knows the Fonz. It's fine. So look, that's really handy, right? Super, super handy. It is really a lot of fun when you've got a bunch of users that belong to a bunch of different groups, and you need to set up some basic permissions where everybody in this group can do stuff in this directory and everybody can do stuff, for this other thing in this other directory, but you need that group ID to follow with the permissions, because otherwise, Bob's going to get in here and Bob's going to make a ton of files, and then I'm not going to be able to do anything with Bob's files because the permissions are not set correctly. We can even see that the permissions are right. I've got read-write access, devs has read-write access, and everybody else in the whole world has read-only access. I'm going to actually RMA again, going to become root again, and we're going to do Chmod 770 devs. So now we reread the permission. We see that we've got the owner, root, has read, write, and execute. Devs has read, write, execute, and S. So S is showing now instead of X. Important to note. And then everyone else, or other, or world, depending on what Unix reference you're reading, the last set of permissions, nobody has permissions to do anything in there. Going to become my ordinary user again. And I've touched A. And as we can see, the A file in here has the read, write, read. It did not inherit the GUID, even though we had set the parent folder to where the world can't list contents here, we still have the letter A, or the letter A would still be accessible. Now, the world is not going to be able to list the contents of this directory, but if they knew the file name, they would still be able to access it. So, something to keep in mind with system security. something to keep in mind with system organization and groups and users and that sort of thing. Without further ado, let's move on to the next section, because I think we've talked enough about users and groups and all of that stuff. Hopefully it'll sink in. There's going to be a lot of exercises. You're going to need a lot of practice here to really understand it and have a clear mental picture. This is just an overview. This is just telling you what you need to know in order to answer your own questions and look at the man pages and figure out how it's all really organized. So this is like the 5-minute introduction, in all honesty.